Hello everyone, welcome to Edu Plus Leisure YouTube channel. So today I am going to continue the discussion of 2010 A-level MCQ paper from the 11th question. A, B and C are three metals under standard conditions. When B is placed in A2 plus or C2 plus, it is oxidized. So when you keep B in the solutions A2 plus or C2 plus, it is oxidized resin. That means A2 plus and C2 plus are reducing to oxidize B. That means B has more negative electrode potential. That is why it was oxidized in the presence of A2 plus and C2 plus. So among the given metals, definitely B should be zinc. But when you keep C in a solution of A2 plus, C is not oxidized. That means A2 plus cannot reduce and oxidize C. That means A2 plus have more negative electrode potential than C. So if something is reducing, the electrode potential should be more positive. A2 plus is not reducing to oxidize C, therefore it has a negative electrode potential than C. That means definitely A2 plus should be lead and C should be copper. So A is lead, B is zinc and C is copper, therefore answer is the first one. The compound CH3CH2C double bond OCH3, so this is the ester molecule, it is reacted with aqueous NaOH. So you know when you put ester with NaOH, first the carboxylic acid part and the alcohol part will separate. Okay, C double bond OH and CH3OH will be producing. Then this carboxylic acid will further react with NaOH and form the salt of carboxylic acid. So this is that salt. You can see these are the products there. Fourth one is the answer. Consider enthalpy changes for the three reactions given below. Okay, it's a minus A, minus B, minus C. Yes, this is formation enthalpy. It is exothermic. You have to find the decreasing order of the numerical value of the enthalpy changes. Now formation is exothermic, but you can see in the first one and second one you have H2 in the first reaction. That means H2 bond has to be broken and only form the water molecule. Therefore, some amount of energy will be used for the bond breaking. In the second one, H2 and O2 both will be using some energy to break their bonds. So when energy is used to break their bonds, then released energy will be less. But you can see third one, there is no any bond breaking, just hydrogen and oxygen has to unite and form the water molecule. Therefore, that only will release the highest amount of energy. C is the highest. Then you can cut 4, 2 and 5. Now you have to compete with 1 and 3. Now in the second one, B reaction, second reaction if you take, bond dissociation H2 has to be broken, also O2. Then what happened, released energy will be. Okay, now let's look at the 14th question. When a mixture of 4 grams of sodium carbonate and sodium hydrogen carbonate was heated, the loss in mass was 0.31 gram. The percentage of mass of sodium carbonate in the mixture is. Now we know inorganic point that sodium carbonate is not decomposing, so only sodium hydrogen carbonate will decompose in this manner. So this is the balanced equation giving you sodium carbonate, then water and CO2. Now they are saying the loss. Now when heated, water also will be in the gaseous form. Okay, therefore this both is only 0.3. Loss in mass means some gas only has to be produced, therefore it will be considered as a loss in mass. So water, vapor and carbon dioxide both only 0.31 gram. Now I'll take that these are Y moles are forming. Okay, so each Y now will form. That means sodium bicarbonate present in the mixture will be 2Y. Okay, I'm just taking in unknown values. Now we know the mass of water and carbon dioxide, right? That is 0.31 gram. But Y I have taken is the moles. So when you convert that moles into molar mass, that means 18Y. That is if you want to find the mass, that is equal to moles into molar mass, no? So moles of water is Y, molar mass is 18, therefore 18Y plus 44Y, because molar mass of carbon dioxide is 44. That is only equal to 0.31 gram. Okay, that's equal to 0.31 gram. Then next we have to see, now we have to find the mass percentage of sodium carbonate. No, I'll take that as X. Okay, moles of sodium carbonate in the mixture I'll take as X. Now I'll find the sodium bicarbonate mass, that is 2Y times 84. 84 is the molar mass of sodium bicarbonate plus Molar mass of sodium carbonate is 106. So 106 into X is equals to 4 gram. So if you find a value for Y, then you can substitute that and find X. X is the moles of sodium carbonate. So if you know the moles of sodium carbonate, then you can find the mass of sodium carbonate. Then dividing by the total mass, you can find the final outcome. Okay. So Y is 0.005. Y. That means we don't need this equation also actually, because if you find Y, you can automatically find the moles of sodium bicarbonate, no? So moles of sodium bicarbonate is 2Y. That means 0.005 into 2, no? 0.01. So that is the moles of sodium bicarbonate. So let's find its mass. So mass is moles into molar mass, no? 0.01 into 84, that is 0.84 grams. Okay, 0.84 grams. Now we have finally found the mass of sodium bicarbonate. How did we find it? We took this 18Y plus 44Y is equal to 0.31 gram. That is the total mass of water and carbon dioxide. Keeping that, I found Y. Y is the moles of water and carbon dioxide form each. So if you multiply by that 2, you will get the moles of sodium bicarbonate. If you know the moles of sodium bicarbonate, you can find the mass of sodium bicarbonate by multiplying by the molar mass. Then you got it as 0.84. Now total mixture is 4 grams. If you minus 0.84 grams, that is the mass of sodium carbonate. Okay, that is the mass of sodium carbonate. That now you have to divide by the total mass and multiply by 100%. So let's do that. So 4 minus 0.84, that is 3.16. That you have to divide by 4. It is 0.79. 0.79 if you multiply by 100, it is 79. You can see exactly 79% is coming. So see, a small inorganic point is also linked with this calculation question. Therefore, we have to be very careful when we are handling with redox. So answer is the fourth one. 15th one, the equilibrium constant at a particular temperature of the reactions are of this and this is K1 and K2 respectively, the equilibrium constant of the reaction. So this first we'll write for K1, will you? So we know the equilibrium constant we find by the equilibrium constant K1, that is equal to the concentration of the product raised to its power. So concentration of, I'll take the B gas, will you? And now you have 2 B gas, that is raised to a power, over A gas, that is K1. Same way K2 is concentration of C into concentration of D over concentration of B. So what you should receive is K3. K3 is for this equation. You have to get then C squared into D squared over A. So this is what you have to receive, C squared into D squared over A. See, now C has to be squared. Now therefore K2 you can square. Okay, when you square the K2 equation, then K2 squared, C squared, D squared, B squared, and then you multiply that by K1. K1 is B squared over A. And you can see B squared cancel, C squared into D squared over A. So K2 squared into K1. Yes, so answer is the third one, K2 squared into K1. So I hope that's clear. Nice question. Then let's move on. Uh, 16th question, which of the following statement is not true regarding the subatomic particles? Electrons show both wave properties and particle properties. Electrons in an atom are dispersed in three-dimensional regions of space around the nucleus referred to as orbitals. The neutron was driven when beryllium was bombarded with high-energy alpha particles. Neutron is an uncharged particle with its mass approximately equal to that of proton. Number of protons in an isotope are different from an element are different from it. So that's wrong, no? Number of protons in isotopes are same because it's the same element. Mass numbers are different. They have the same atomic number. So the not true one is fifth one. Consider statement given below regarding 1-butane. So when they say like this, first we have to draw this, okay? So but means 4, no? 1, 2, 3, 4. So 1-butane, the first carbon has triple bond, no? Ion is triple bond, no? Then one hydrogen here. Okay. All carbon atoms of this molecule lie on the same straight line. Now this carbon atom is linear. This one is linear. This one is linear. But these are tetrahedral. So they will bend. So they are not in the same straight line. It reacts with NaNH2 and evolves H2. Yes, it has acidic hydrogen. It is reacting with NaNH2, but it will give ammonia, right? Not NH2. Yeah, it gives ammonia. It decolorizes bromine water. Yes, Br2 can react with it. It reacts with Ag plus and form a silver mirror. Now acidic hydrogen with silver actually is giving a precipitate, not silver mirror. Therefore C only is correct for. Okay, the 18th question. Solubility product of Hg2Cl2 at 25 degrees C is 1.2 into 10 to the power minus 18. Okay, Hg2Cl2, it will dissolve into Hg2 2 plus and 2Cl minus. So if you write the KSP reaction, that is Hg2 2 plus concentration into Cl minus concentration twice, okay, I mean to the power 2. Now there is NaCl solution saturated with Hg2Cl2. If NaCl concentration is 0.04 mole per decimeter cube, that means Cl minus concentration is also this. Now we know that it will so we just have to now put to the equation and find it. So KSP is 1.2 into 10 to the power minus 18, that you have to divide by the Cl minus concentration squared. So that Cl minus concentration we can take as 4 into 10 to the power minus 2, 4 into 10 to the power minus 2 squared. Okay, so that is actually 16 into 10 to the power minus 4. So 10 to the power minus 4, 10 to the power minus 18, it becomes 10 to the power minus 14. 1.2 divided by 16. (0.075) into 10 to the power minus 14. 0.075 into 10 to the power 0.075 into 10 to the power minus 14. Then if you move 2 decimal places front, it will be 10 to the power minus 16. Oh yes, 7.5 into 10 to the power minus 16 is the answer. So directly from the KSP equation you can get this. The increasing order of the acidity of the hydrogen atom marks as A, B, C. Okay, let's see that. So B, you can see that is a acidic hydrogen, no terminal hydrogen with alkyne. So A is a hydrogen with C. And now here you can see alpha hydrogen. This C is, we call a alpha hydrogen because it is with the aldehyde group. The hydrogen, C double bond O, it's a aldehyde group. So the adjacent carbon bearing hydrogens we call as the alpha hydrogen. So alpha hydrogen is the most acidic, okay. It's most acidic than terminal hydrogen as well as this terminal hydrogen. Anyway, B, the hydrogen B is more acidic than the CH3. We obviously know that, okay. Therefore, C is the highest. Next highest is B. Next highest is A. Simple questions. Which of the following statement is true regarding the pattern shown in the S and P block elements in the periodic table? Atomic size decreases downward the group. No, it increases, no. Atomic size increase across the period from left to right. No, it decreases. Ionic radius decreases downward the group. No, that also will increase actually. Metallic nature increases across the period from left to right. No, that's decreasing. The basic nature of the oxides and hydroxides decrease across the period from left to right. Yes, because we know that metallic oxides only basic. Metallic nature is decreasing now across the period. Therefore, the basic nature of the oxides and hydroxides also will obviously decrease. So that's perfectly correct. So now I have discussed the next 10 questions also. So wait for the next videos. Thank you for watching.